So today we are going to derive the limit of x plus 1 over x square plus 3 as variable x approaches infinity. Now here we can see that the degree of the bottom is 2, which is greater than the degree of the top. So simply the limit will be equal to 0. It doesn't matter that the variable x approaches infinity or negative infinity. Whenever we have degree of bottom is greater than the degree of top, the limit will be 0. Now let me show you the whole method. How can we get this equal to 0? So this will be equal to limit x approaches infinity. Now since the largest power of the variable in the denominator is 2, so we will divide whole function by x square. So x plus 1 times 1 over x square, and here x square plus 3 times 1 over x square. So this will be equal to limit x approaches infinity. X over x square is 1 over x plus 1 over x square, and in the bottom x square over x square is just 1 plus 3 over x square. Now we know that whenever we have bottom heavy function, its limit as x approaches infinity is 0. So limit of 1 over x is 0 plus 1 over x square is also 0. In the denominator, limit of 1 is just 1 and 3 over x square will be 0. So this is equal to 0. So whenever we have bottom heavy function, we can write its limit as x approaches infinity is equal to 0 directly. Now let us see one more example of a bottom heavy function. Let us derive limit 10x raised to 5 plus x raised to 4 plus 31 whole divided by x raised to 6 plus 5 as x approaches negative infinity. Now here also we can see that the degree of the bottom is 6, which is greater than the degree of top, which is 5. So we can write this limit directly as 0. Let us see how can we derive this equal to 0. So this will be equal to limit x approaches negative infinity. Since the highest power in the denominator is 6, let us divide top and bottom by x raised to 6. So this will be equal to 10 x raised to 5 plus x raised to 4 plus 31 whole divided by 1 over x raised to 6. And also in the bottom we will have x raised to 6 plus 5 whole divided by x raised to 6. So this will be equal to limit x approaches negative infinity. 10 x raised to 5 divided by x raised to 6 will give us 10 divided by x, plus x raised to 4 divided by x raised to 6 will give us 1 over x square, plus 31 divided by x raised to 6 whole divided by 1 plus 5 over x raised to 6. Now let us plug the limit as x approaches negative infinity. So 10 over negative infinity will be 0, plus 1 over negative infinity square will also be 0, plus 31 over negative infinity raised to 6 will also be 0. In the bottom we will get 1 plus 0. So this is 0 over 1 will give us 0. So whenever we have a bottom heavy function, the limit will be 0. It doesn't matter whether the variable x approaches infinity or negative infinity. Now let us see one more example in which the degree of top and bottom both are equal. Let us evaluate limit 2x cube plus 7 whole divided by x cube minus x square plus x plus 7. Let us evaluate it as x approaches infinity. Now whenever we have degree in the top is equal to degree in the bottom, the answer will be the coefficient of the x cube divided by the coefficient of the x cube in the denominator, which is 1. So here 2 over 1 is equal to 2. Now let us see how can we evaluate this equal to 2. So let us divide top and bottom by the x cube. So this is equal to limit x approaches infinity 2x cube plus 7 whole divided by x cube. And in the bottom we will have x cube minus x square plus x plus 7 whole divided by x cube. So this will be equal to limit x approaches infinity 2x cube over x cube will give us just 2 plus 7 over x cube. In the bottom we will have x cube over x cube is just 1 minus x square over x cube is 1 over x plus x over x cube is 1 over x square and plus 7 over x cube. Now let us plug the limit as x approaches infinity. So limit of 2 is just 2 plus 0. In the denominator we will get 1 minus 0 plus 0 plus 0. So this is 2 over 1 which is equal to 2. Now let us see one more function in which degree of the denominator is smaller than the degree of the numerator. So let us evaluate the function, the limit x approaches infinity 5x raised to 8 minus 2x cube plus 9 whole divided by 3 plus x minus 4x raised to 5. In this function we can see that the degree of the bottom is 5 which is less than the degree of the top which is 8. So here the limit is negative infinity. Since the coefficient of x raised to 8 is 5 and the coefficient of x raised to 5 in the bottom is negative 4. So this is a negative number, and since x approaches infinity, this will be equal to, this will approach to infinity. Sorry, this will approach to negative infinity. Now let us see how can we derive this. Okay, so let us divide the top and bottom by x raised to 5 since the degree of the bottom is 5. So this will be equal to limit x approaches infinity 5x raised to 8 minus 2x cube plus 9 whole divided by x raised to 5. And in the bottom we will have 3 plus x minus 4x raised to 5 whole divided by x raised to 5. So this will be equal to limit x approaches infinity 5x raised to 8 divided by x raised to 5 will give us 5x cube minus 2 over x square and plus 9 over x raised to 5. Now in the bottom we will have 3x raised to 5 plus 1 over x raised to 4 minus 4. Now let us plug the limit directly. So this will give us 5 into infinity cube minus 0 plus 0 whole divided by 0 plus 0 minus 4. So this will be equal to minus 5 divided by 4 infinity cube. So infinity cube is just infinity, and infinity multiplied by a negative number will give us negative infinity.